Right, I've got my new circuit breadboarded in front of you there. So I'm using OPTO isolators to decouple the signal from the coils, and the coils are in series, so that basically what happens is the first coil triggers on, then we have a second coil which is in series with that coil, which basically subtracts the signal from the first coil. So what happens is, while the duration of the pulse might still exist on the first coil, the second coil kicks in and subtracts that and basically turns it off. So and because it's working in AC, it works in both half cycles. So one half cycle triggers the top OPTO isolator, the second half cycle triggers the second OPTO isolator, and because they're actually wired in parallel, but they're in inverse parallel, so when one is on, the other's off, and when that one's on, the other one's off, so that we can switch AC. And I was quite surprised, because at first I was very disappointed. I'll tell you why. Well, when I first connected the circuit up and I was running it, I was drawing 400 milliamps on my power supply, but my output was, guess what, 15 milliamps. 15 frigging milliamps! That's when I tuned it, so I got maximum RPM at about 4,000 RPM, which is what I'm getting right now. So, and I thought, oh, look at that. I thought, this is not going to work. And then I realised, I thought, hang on a minute, I haven't got my timing right. So I pulled the coils out, which were on top in there, in this slot here. They were down in these slots. And I sat them on the top here. So the coils are actually sitting outside the unit on the top. These are the trigger on coils. And 60 milliamps. And less power in. And good RPM. So I'm thinking, bloody hell, I've got my trigger coils in the wrong places. So what I'm thinking about doing is moving these trigger off coils that are down there and sticking them underneath down there to test that as well. I can actually do that maybe while it's running. I don't know if it's going to make a difference, but what's interesting is the current on the input and the actual current on the output. Yeah, it's really cool actually. I'm really quite excited actually about this, but let me just try and get these out while it's running, because these wires in the way. I don't think oh no, I can't get it out because these coils dangling down here. If I try to pull these out, I'm going to rip my output out off, so I can't actually swap these bottom coils out. I was going to grab that wire there and just pull them out, but I can't because these output the output wires are actually dangling over the top. The clips are going to get jarred and pulled off, and then everything is going to go totally cock off. But what I'll have to do is I'll have to extend these output coils and bring them around the side so I can actually move the bottom coils. But now look at the timing on these trigger coils. Now if I just move these trigger coils, just tilt them up, look at my current, it's gone down, right, it's gone down. Now watch, hang on, let's see. Right, so it's gone back up again because I've let them rest again, but when I lift the coils up, let's see what happens on the input. My input's gone down a bit as well, but my RPM's actually going up a bit, but that's to be expected. Now just getting these coils in the right place just by moving them around. I don't know if it'll work from right back here though, because I have to get pretty close to the rotor, which is in there. Now if I put them in the slots where they were before, right, put them in the top slots, because I can move these around without too much trouble while it's running. Now look at my current now, it's gone down, and my input RPM. I can't remember now what it was before, but it looks like it's gone down to me. Right, let's just pull this out. Let's see what the RPM does. Yeah, it seems to have gone down. Pulling these coils out again, and we'll stick them back on here. It's speeding up. I think it was. Right. Anyway, when I had it, of course I've adjusted all this lot as well. So I've tweaked all these pots with these in this position, so it does seem to work a lot better with them on top, which is really quite cool. Anyway, I was really disappointed earlier because I was only getting 15 milliamps, and my RPM dropped like a stone. It went right down to 2,900 RPM. I'm just trying to push this blue tack back on here. It went right down to 2,900 RPM with just 15 milliamps output. And I thought, what? That's a joke. And I was drawing 500 milliamps earlier. So yeah, I've swapped the coils round. I also flipped them round, which reverses the polarity for the trigger circuit. I've done a few things. Anyway, I thought I'd film it because it was kind of cool. Well, that's all. So anyway, the current's gone down a bit. I know why. It's because I'm charging up the silver capacitors up there, which you can't really see at the moment. But the voltage is climbing at the moment, so the silver capacitors are getting 30 milliamps at the moment. Oh, I think that's 30, or is it? I don't know. Should be 40. All the LEDs on that display are using some of the power. So yeah. So that's charging up slowly. So that's another reason why my current's just gone down a bit, because as the voltage climbs, the voltage, the current relationship changes as well. But yeah, that's pretty encouraging. I mean, it's early days. I mean, don't get me wrong. This is very early days, really. But it's all positive signs. And now that I know that by having my coil sort of in between that slot, which is at the top, and this slot, which is down here, I can 3D print. Oh, I wasn't going to 3D print anything, was I? Oh well, it looks like I'm going to have to 3D print a little V-shaped thing that will sit in there and hold these bobbins at this angle, because they need to be tilted up like this, ideally. I think. Let's see. I'm not sure actually. My current seems to have gone up when I tilted them up. No, it went down, sorry. It actually goes up when they're actually... That's really strange. That's really strange actually, how just by moving the frigging coils, just by moving them about 45 degrees, it makes a hell of a difference. Actually, it is going up, the speed's increasing. So they are better in that position because the speed starts to increase. So when I've got them like that, the speed starts to go up, and as the speed increases, my output also goes up as well. So you've got to wait for the speed to catch up, basically. So yeah, right. But I need to put a rubber underneath these to hold them up. But anyway, I'll just lay them down for now. But look, I've laid them down. Actually, current's going up. I'm very confused. It's very confusing. You see that there's a lag time, right? There's a lag time between when something happens on the meter and when the RPM changes. So you've got to wait for the RPM to catch up, and it's very confusing sometimes. And another problem, when I'm trying to tweak these pots down here, I'm looking at my RPM to get the maximum RPM, and then when I look at my meter, the current's gone down. I'm thinking, oh shit, so I'll turn it the other way to get my current back up, then I look at my RPM meter and then that's gone down. So you've got to balance it in between. You've got to look at both things at the same time, and it's difficult to do that, really. It's very difficult because you're trying to focus on one thing and you can't really focus on one thing. You've got to look at two different things. And the input current as well, there's that to watch. So there's three things to watch. And yeah, it's just driving me up the wall, really. But anyway, I got my circuit board, the design done. I'll show you what it looks like. I haven't made the board yet, but I've got it up on the... I haven't muted myself, have I? I hope not. I'll just get it up on the computer a minute. I'll show you what the board's going to be a bit like. I don't know, picking update window coming back. Go away. Right, so there's the circuit. Why does it keep moving everything? It keeps moving everything around. That's the board that I've been... I'll just get a bit closer. That's the board I've been doing the layout on. So I've got to basically print that onto photo paper, and then well, there's paper, and let's look at the 3D thing while I'm at it. So this is a 3D. Oops. Give you a rough idea anyway, but there's the OPTO isolators there. I don't know if you can see my mouse, actually I can't see it on the screen. But anyway, wobbly. There's the OPTO isolators, there's my trigger coil inputs. These are sockets really. And then there's my MOSFETs, which are down there, Q1 and Q2. And there's the back, and there's two separate ground planes because it's AC. So I basically got a ground plane for one half cycle and a ground plane for the other half cycle, which is simply connected to the drain. Is it drain? Oh, hang on a minute, I can't remember now. I think it's drain. Wrong one. No, it's source. So it's connected to source actually. I always get these mixed up for some reason. So the source there is the ground, AC ground basically, but it's not a permanent ground. It's intermittent because it's AC, so it's constantly swapping. And right, so I'm trying to hold this phone without pressing any buttons on it. That's why it's wobbling. I'm holding it at the edge. So anyway, that's the board which I've got to make. It's just getting the coils in the right places really, and filling about and optimizing everything. And I really want to be able to change the turn off coils as well, which are the bottom ones. Those turn everything off, and I need to move those around to optimize, to get rid of that drag. Try to get rid of that drag, I should say. So anyway, but yeah, current is better than what it would have been, and I can increase the current by increasing these trimmer pots here. So let's have a look. I'm turning them up slightly. Each one I've got to do each one. I've got to do each one, then go back and forth, back and forth. Right. Interestingly, while I've been turning them up, my current consumption hasn't shifted. That's really cool. Hasn't moved. And my RPM. That's strange. That's weird. Because normally when I turn these up, it slows down. Let's turn them down, see what happens. Because it must have got the coils in exactly the right place. My current RPM, what's it doing? It's going up very slightly. That's quite surprising. Oh, that's weird. Let's turn this up down a bit more, because turn these down a bit more. Let's go right down. Right, I've turned both of them right down, and I've only dropped to 41 milliamps. Bloody hell! Huh, that's weird. Earlier on when I was turning them down this much, it dropped right down to like 10 milliamps. And now it's only dropped to 41 milliamps. That's pretty cool. Turned them down a long way as well. Mind you, the coils are set further back, so I don't know if the signal's a different shape or something. Because they're going for these OPTO isolators down here. There's two OPTO isolators down there. And as long as they're getting biased, the voltage coming through will be quite large anyway, so... Ah! Now I'm seeing the difference. Now it's dropped down to 22 milliamps. 24 milliamps. It's going back up because the RPM's increasing. Look, climb it back up again. That's really, really interesting. So my RPM's now going up, and my current's now going back up again. I mean, listen, look at that. It's gone right up to 4,608. My current's still climbing. Yeah, and my input current 330 milliamps. At the moment, the voltage is set to 13 volts on the input to the trigger pulse circuit. So I'm actually doing some tests which I haven't done yet. So you're seeing what I'm seeing basically. Let's turn this down a bit more. Right, it's climbing again. Look, it went down and it's climbing again. Holy shit! Oh no, I'm at 5 point. Oh, I'm at 5 point, not 64. I was confused then. I thought, what? No, there's a decimal point down there. So I'm at 6.8 milliamps right now, so it's very low right now, and I'm at 5,000 RPM. So I need to turn this back up again. I'll turn it back up while you're watching the meter. Right, we're back to 59. Look, let's turn this. See if I tweak this so that it's optimized with speed as well. I can hear the tone change, the speed change when I'm not talking. I'm trying to turn each one so it just shoots up. Turning it right down. Turn that one down, back up. I'm trying to get both channels balanced. And then turn each one up by about 1 millimeter. That way I can get my speed up, and once I got the speed up on the RPM, then the main thing is to keep the current low on the input. I'm just slightly offsetting them a bit. I'm going back up again. Right, I'll leave it there. So I've set the trimmers about about 1:30 or 1 o'clock positions at the moment. They're both at about 1 o'clock, 2 o'clock maybe. No, 1 o'clock I think it is. So I've got both of them trimmers at about 1 o'clock position. I don't mess with the input trimmer pots because those are to switch the OPTO isolator, and there's no end stop resistors on there, and I've got to be careful because if I turn them too high I could damage my OPTO isolator. So I'll just 100Ks, each one of them is 100K, so those two trimmers I'll just set them and get them right so that the OPTOs are working well, and then I leave them, and all the timing really is done for these two trimmers here, which goes to these MOSFETs down here. So anyway, 43 milliamps. I'm happy with that for now for the testing, because I'm only using these little tiny MOSFETs, and these are BS 170s. The maximum current they can handle, I think, is 600 milliamps, or is it 500 milliamps? I'm not sure. It's either 500 or 600. Anyway, but I'm not too worried, because my bridge rectifiers that are rectifying this, which are over here, down here, each one of those can only handle 500 milliamps anyway, so I'm not going to be going that high anyway. So anyway, I'm nowhere near that, so I'm not worried, unless there was a direct short, and yeah, it could cause a problem. But yeah, the circuit's working pretty well. I've got some little inductors to try to filter out any ringing. You always get a bit of ringing when you stick a diode on the output of the MOSFET, on the source output. The reason you have to put a diode is because there's a blocking diode inside the MOSFET, which it would short it out the other way, so you'll have to put a diode in series to prevent you shorting it out the other way, the other direction. So I use a diode, it goes through, then it goes back on the return line, not that wire, which one? This red wire, it's on the return line to this other AC input. The two AC inputs are a red and a white, which go to these clips here. So these are basically in series. Actually, it's in series with the coils. Anyway, it's fun. We're having a lot of fun at the moment. Not always fun. It's sometimes very disappointing and boring, but yeah. So what I'm going to do now? Oh, my current input. What is it at the moment? It's 360. No, it's not. It's dropped quite a bit actually. 360 milliamps. But already 42 milliamps coming out. But that's into 4.65 volts on a supercapacitor. So that's not a great deal. But if I can just get these timing coils in exactly the right place, and I don't want to be messing about making adjustment alterations to my design. Obviously I don't want to be doing that. If I can just stick the coils on the outside, that's fine, as long as they work, because as I said, there's a massive field. There's a really big magnetic field that comes off these rotors, as I showed you previously. One of the rotor drums, I mean, they've got a lot of magnets in them, so the field extends quite a long way out of here, so these coils can pick up that signal quite well from quite a long distance away, really. Nothing else to talk about other than the fact I'm still experimenting with it. I'm still making adjustments and getting a few surprises. Oh, I took my capacitors off the gate. I had some, these capacitors on the gate, which are 330 picofarads. I took them out temporarily to see if that would improve the timing signals, and it does seem to have made a difference. So I might not even need the 330p's, but I mainly put them in there as protection for spurious ringing on the gate, because you don't want the gate to be oscillating. You want it to be latched on and then off. You don't want it to be oscillating, because that causes the MOSFETs to heat up, but it can also cause them to ring as well. So this MOSFET here was getting quite warm earlier, so I thought, I'll take that capacitor out and see if that makes it cool down a bit, and it seems to have done so. I might have been getting a little bit of oscillation in the circuit, because there's still a bit of ringing. You can see it on the oscilloscope. So let's just expand it. You see there's quite a lot of ringing on there. I need to get rid of that. That ringing is unwanted. It causes the MOSFETs to get hot. It heats them up because they're not stably on and off, latching properly. So yeah, anyway, that's it for now. I'm going to disappear, and thanks for watching.